In this video, I'm going to show you how to use prop.test to perform a two-sided test to compare two population proportions. To start, you're going to need to have a set of null and alternative hypotheses. So we'll have a null in this particular case that the proportion of successes in one population is the same as the proportion of successes in the other. Then we'll have an alternative, and I'll write this in R notation on the screen here, that the proportion of successes in one population is different than the proportion of successes in the second population. Now what we'll also need is to decide upon a significance level, a probability of a type 1 error. In this case, we'll just use 0.01. And then we'll need to make up a rule for rejecting our null hypothesis. In this case, we'll just use the p-value rule. We'll say we'll reject our null hypothesis if our p-value is less than or equal to our significance level. And then what we'd have to do is go out and collect our data in such a way that we meet four assumptions. The first two assumptions are the same thing basically. They're saying that we have a simple random sample from our first population, and the second assumption is saying that we have a simple random sample from our second population. Then we'd have to check both these samples to make sure that there's at least 10 successes and 10 failures in each. So we're just going to pretend like these are all satisfied here. The last two are, the first two are not going to be, just because in this particular case I made these numbers up. But if we look at our data up here, yes indeed we do have at least 10 successes and 10 failures in here. So I can go ahead and perform this test, and I can say to myself, well, I'm going to use this prop.test function. And the way this guy works, it's very similar to the way you do it when you only have one population. You'd start by typing in a number of successes, but in this particular case, the number of successes have to go in as a vector. So I'd have to say, well, there's 24 from my first population, and there's 52 successes in my second population. Then what you'd have to do is tell it the sample size from each population, and that's got to be a vector also. So from my first population, I had a sample size of 100. That's a nice round number here. And from my second population, I had a sample size of 200. Then what you'd need to tell it, well, unlike the single population case, you don't have to tell it a p0 value, because that doesn't matter for this one. What you'd actually have to just tell it next is what the alternative option is. So in our case, we're doing a not equals in the alternative, and that translates over into a two-dot-sided test, like that, and then we'll leave the rest of the options alone. They'll make a small difference between this and what we would have done in class, but that's fine. And so I'll just run this. And so what we get back here is just the standard output, and what we'd want to check is that we have the proper alternative there. Okay, we want to check that we have our data typed in here correctly. We'll notice this says we have two samples in this particular case because that's what we're doing. And then we want to look at our p-value here. In this case, our p-value is 0.8145, and we want to compare that to our significance level. And according to this, that is not less than 0.01. So this would be a case where we would decide to fail to reject our null hypothesis. Now, normally, if you had real data, you'd be able to interpret this in some way, but right now, this is just fake data, so this is as far as we can go with this, is just to decide that we're going to fail to reject our null hypothesis. Okay, so that's how you can use the prop.test to do a two-sided test to compare the proportions from two different populations.